So let's get the higher derivative started. Now, you know that normally we are given a function of f of x. Now, the y dx, meaning the differentiation of that function y, is same thing as the dx of what? F of x. Now they can also write it this way: f prime of x. This is called first derivative. What do I call it? First derivative. Now second derivative is when you are differentiating the first derivative, that it is written as dy is equal to y dx squared, meaning the differentiation of the first derivative. Can you see? So this is d squared y dx squared, and can also be written as f prime prime of x, meaning second derivative, or y prime prime. This one can also be written as y prime. So this is what we call the second one. Now the third one is also differentiating the second one, that is the dx of the squared y dx squared, meaning equals d cube y over the x cube. And we can also say it is y prime prime like this, and we can also say is a prime 3 of x, right? Now this is third derivatives. Now let's go into the examples. So we have this example number one and number two. We have to find first and second derivative. Now number one, y equals to x plus 4, 11x plus 1, and 3x plus 2. And some of you want to use what is it called? Product rule of three functions. But why can't you just expand and since they are not having any power, just expand straight away. I have I can choose to expand the first this thing here. That will be what? 11x times 3, that's 33x. Then 22x plus 25. So that's plus 25x, right? Then plus 2. That's the expansion. Again, 33x, 22x, 3x, that's 25x, then plus 2. So we can now expand using that will be y equals to, we have 33x squared, thus this is square, sorry, that will be cube. So plus 25x squared, then plus 2x, then you can multiply this. 33 times 4, 120, then that's 132. So 132 x squared. If I'm right, yes, 132 x squared. Then plus 100x. Now plus what? Plus 8. So you collect the light and that what? 33x cube. 25 plus 132. That's what? 157. 157x squared plus 102x plus 8. So find the first derivative. First derivative is what? 99x squared plus 314x, then plus what? 102. Then this will be 0, right? So if you want to find the second derivative, what's the second derivative? That will be what? That will be what? 198. So this will be 198x. That's second. That means you are differentiating the first. That's 198x plus what? 314. Right? So this is the answer. Are we here now? So now let us move to the second example. So this is the second example. Now y equals to sec square x. I can write it as sec x or squared. And you know that obviously we are using composite rule here, or we say function of function, we say chain rule. All right. So now I will let you be what? Sec x, like we always do. Then I will say my I'm finding divide dx now. I will say my y is what? U squared. Oya differentiate this. D dx is what? What's d dx? Differentiate sec x. What's that? We have sec x tan x. Shebi, how's how to differentiate? If you check your table, alright, if you differentiate y with respect to u, you have what? 2u. So what is dy dx? Dy dx is what? Du dx dot what? Dy du, or dy du dot du dx, anyone. So what do we have? We have 2u sec x then tan x. So du dx is sec x tan x, dy du is 2u, multiply it together. So what do we have? We have 2. What's the u from the beginning? We have was sec x, then this sec x, then tan x. So definitely the answer is what? Sec square x then tan x. Now you are now asked to find the d square y and the x squared of. So that means you are differentiating the first, you are able to get the second derivative. So what should we use? We all know we are using product rule because I'm having one and I'm having two. We can use product rule, or do you know that I can use this method? What is x? X square x. X square x is the same thing as 2 into what? 1 plus tan square x then tan x. Yes, now I can use this method and I will still be right. But let's just use product rule straight away. Are we here now? Let's use product rule. Product rule is saying this will be my what? My u. This will be my what? My v. So now what is u? So the product rule is what? U v prime plus v u prime, right? Oh yeah, what is my u? My u is this. My u is this, right? So I think I'll just have to put my two outside first, then differentiate using product rule for these two. So that will be u is what? Sec square x. What's v prime? V prime is what? If you differentiate tan x, you have what? Sec square x again. Then plus, oh yeah, what is v? V is what? Tan x. And if you differentiate sec square x, thank God we have differentiated it from here. You follow this product. It is better if you have differentiation inside differentiation, you solve it outside and bring the derivative inside. So that it won't be scattered. Don't start naming another alphabet, so you won't have a rough result. Now all we need to do is just to differentiate what? X square x, and which is u prime. So and we have already gotten the differentiation is still this, abi. So we just write it there, times 2 sec square x tan x, then close bracket. All I need to do is just to expand. So if I expand, what do I have? I have 2, using this 2 to expand, we have what? 2 sec 4x, like this. That's square square, right? Then plus 2 times 2, that's 4. Like that will be 4. This, okay, 4, then sec square x, then tan square x. It's as simple as that. Shikena, are we here now? And if I want to do it very well, I will say let us factorize the common factor. What's the common factor? 2 is common, bring it out. Also sec square x is common. I'll bring sec square x out, then open bracket. What remains here? It remains only sec square x, abi. When you remove this one from this, means sec square x plus, yeah, 2 sec square x, remove this one, 2 tan square x, close bracket. So this is the answer.